All right, this is page 104 of the Incredibles book, and really, you just have to read this. I am not adding much to it. I'm just going to make comments about it, right? Position function is S of t. I'm basically reading it to you, right? The first derivative of the position function is velocity. The second derivative of the position function is acceleration, or you can think of it as the first derivative of velocity is acceleration, right? We've talked about that before. When an object moves, its position changes over time. So we can say that the velocity is the change of the position function over time, right? If we're moving along a horizontal line. So here we can actually talk about horizontal line or vertical line or a third type of line, which is not a line at all, but a curve. So we could be talking about a curve. It doesn't have to be a line, all right? But basically speaking, when the velocity is positive, it's moving to the right. If on a horizontal line, it's moving to the left on a horizontal line. If the derivative is less than zero, if the derivative is zero in either case, the object has stopped. Makes sense. When the velocity is zero, the object has stopped. If I'm on a vertical line and the derivative, the velocity is positive, it's going upwards. If the velocity is negative and it's on a vertical line, it's moving downward. Speed is just the absolute value of velocity. So what it means is velocity has a direction. It's either moving right or left or up or down. When we talk about speed, we don't care which direction it's going. We're just talking about how fast it's moving. All right. The thing to note here. So this is very similar to what we just set up there. And when we talk about velocity, an object is moving to the right if the velocity is positive. When we talk about acceleration, if the acceleration is positive, the object is accelerating to the right. And that's kind of confusing for most people. So what does it mean to accelerate to the right, accelerate to the left? Okay, we're going to address that down here. You can have an acceleration that's to the left, and velocity is moving to the left. So if you're accelerating to the left and moving to the left, you're actually speeding up. Okay, so acceleration and velocity are working together and you're speeding up. But what if your velocity is moving to the left? Okay, I got this backwards. This was moving to the right and this was moving to the right. So that was absolutely backwards. I said left both times. So velocity is moving to the right. Acceleration is moving to the right. So it's speeding up. Here, acceleration is moving to the left. I'm saying all these wrong. Velocity is moving to the left and acceleration is moving to the right. These two are working against each other. Okay, that's the biggest thing you take away from. I know I'm screwing up the language. Okay, so here, velocity and acceleration going the same direction, right? They're both positive, so it's speeding up. Here, velocity and acceleration, opposite signs. Velocity is negative, acceleration is positive. They're going in opposite directions, so we say it's slowing down. If velocity is zero, and it just stopped. It just stopped. All right, velocity is zero, it stopped. Okay, so don't worry about which direction it's going when it stopped. Okay, now if acceleration is negative and velocity is positive, that means they're working against each other again. So it's slowing down. And this one, velocity is negative and acceleration is negative. So that means it's speeding up. Okay, and if acceleration is zero, so it doesn't affect the velocity, it's not speeding up or slowing down, it's just a constant speed. So it doesn't matter which direction it's going, the speed is not changing if the acceleration is zero, so it's constant speed. All right, so conclusion from the table above, when velocity equals zero, I'll stop. When velocity and acceleration have opposite signs, particle is slowing down. when velocity and acceleration have the same sign, particle is speeding up. All right. Somebody bothered by the fact that it's okay. Also, just because you have a positive acceleration doesn't mean that you're moving to the right. For instance, suppose you were walking to the right, velocity is positive. When all of a sudden a large wind started to blow to the left, acceleration is going to the left, right? It's accelerating. What would that do to your velocity? It would slow you down. Okay, that's it. So this was a short video, and you might be thinking, that couldn't have been all. Well, it wasn't. We went over homework the rest of the time. So there should be a video nearby that went over the homework. Okay.